All right, starting lesson 4.3, rotations. All right, this is the new type of transformation we'll be learning about in this lesson. So a rotation is a transformation in which a figure is turned about a fixed point, called the center of rotation. So here's what's happening. You have this figure. All right, you're going to have a point known as the center of rotation, and you could draw a segment to any point on that figure. So we'll just draw a segment right here. All right, and then I'm going to rotate that segment 40 degrees, and it's going to take this whole figure and it's just going to shift it over. All right, rotate it over or swerve it over. All right, 40 degrees. So that's with every part. All right, now you should be reading through all this information so you get all the details. All right, but I'm just summarizing everything and clarifying any points that I think students might have trouble with initially. All right, for example 1, drawing a rotation. So here they give us the figure. Here's our center of rotation. So you're going to draw a segment to a point on the triangle, all right, and rotate that segment 120 degrees. So here's my rotation. You want to make sure the segments have the same length as you see here. All right, that's my new point, A prime. Then I'm going to have B. B prime. Then I have C. Alrighty. There's my C prime. All right, here's how the new triangle should look. Something roughly like that. That's what happens when we do a 120-degree rotation. Okay, now this portion here just talks about how you could rotate a figure up to 360 degrees. And if you do so, you simply get back to where you started. So if I go from here and I rotate 360 degrees, it just takes me back to where I started. All right, now there's a couple rules for rotations that take place about the origin. So if you're rotating, you're from the origin, or your point of rotation is at the origin, here's some simple rules. All right. For 90-degree rotation, this is what happens to any point. Your point AB, the values, they flip, and then the B becomes negative. For 180-degree rotation, the values stay where they are, except they become negative. For 270-degree rotation, the values flip, but then the A value becomes negative. Okay? So this is very important to keep in mind when working with rotation problems. All right, let's do an example applying this concept. Alrighty, so it says graph quadrilateral RSTU with vertices. All right, here are the points of the quadrilateral. Quadrilateral means it has 4 sides. And its image after a 270-degree rotation about the origin. Okay, so here's the property we'll be applying here. All right, so they take every point and they apply the property. They switch the values and they make the A value negative, which is what they did with all of these here. All right, and then you just plot your new quadrilateral. That's all there is to it. All right, really simple once you get the hang of it. All right, the next part just describes how a rotation is a rigid motion. Rigid meaning it doesn't change the shape of the figure that's being transformed. All right, nothing changes about it. All the sides are congruent, all the angles are congruent. All right, let's go into another example where here we're performing a composition of transformations. First we're doing a reflection, then a rotation. All right, so we start off with RS. Here I have RS. All right, and we're reflecting over the y-axis. All right, so here I'm 1 unit away, so I'll be 1 unit away on the other side of the y-axis. Here I'm 2 units away, so I'm going to be 2 units away on the other side of the y-axis. Then from there, we apply the 90-degree rotation about the origin. All right, so here's our 90-degree rotation. All right, and there's the property you can apply for a 90-degree rotation, which is you flip the values and then you make your x value positive. So the values have been flipped, and this was originally negative, now it's positive. All right, once again, for a 90-degree rotation, you switch the values, and then you make the x value positive. All right, and that's what we have right here. Done. All right, identifying rotational symmetry. All right, so what it means is that what types of rotations are there where you will have an identical figure? Well, here, if I rotate 45 degrees, do these figures look the same? Do they overlap perfectly? No. But do these look the same? Do they overlap perfectly? Yeah, they do. And so do these. All right, so rotation of 90 degrees or 180 degrees yields the same figure, or mean a figure oriented in the same way. All right, so for example 4, identifying rotational symmetry. All right, for a parallelogram, is there rotational symmetry? All right, so what we're going to do is draw the diagonals. Oh, that's a terrible diagonal. Draw the diagonals. All right, and your point of rotation is right there. So if you do that, let's see, if we rotate it 180 degrees, it's going to look something like this. All right, that's if we rotate it 90 degrees. But if we rotate it 180 degrees, it's going to be back lying onto itself. All right. So 180 degrees. For a regular octagon, here's the point of rotation. All the diagonals intersect. All right, there we go. So we could rotate it many times and it overlap with itself. Well, let's see, we could divide it into, since we're working with an octagon, we could rotate it 8 times, right? And it's going to shift every time, all right? And if we rotate it 45 degrees, it overlaps with itself. So every time we rotate it another 45 degrees, it's going to overlap with itself. So 90 degrees, 135 degrees, and 180 degrees, all right? And it will always overlap with itself. All right, then we have the trapezoid. All right, this one's a little tricky. Let's see, if I rotate it, like say 90 degrees, it's going to look something like this. No, if I rotate it 180 degrees, it's going to look like this. Does it overlap with itself? No. So we stop at 180 degrees. We don't rotate it anymore after that. So it does not have rotational symmetry in this case. All right, that's all there is to it for rotations. If you have any questions, if you need any clarification, please make sure to ask for help. Begin the assignment.